In this video, I am going to compute the expected value and the variance of the value for the sum of two dice. Now, I've already computed the probability distribution for the sum of two dice. This is the possible outcomes for the sum. This is the probability of each happening. So, expected value is simply the possible outcomes, the sum of the possible outcomes times the probability of that outcome. So we can do sum product of the outcomes and times the probability of those. And we get 7. Another way to do this calculation, so this is our expected, another way to do this calculation would be to say, well, the expected value of the sum of two different events is the sum of the expected values. So if we think about the expected value of rolling a die, well, they're all of equal probability. So that's going to be the sum of 1, 2, 3, 4, 5, 6 divided by 6, or 3.5. The expected value for rolling two dice, therefore, is twice that, 7. Okay, variance is a little harder to calculate, but again, we can do it. So the variance is going to be the sum. Maybe we'll just create a new column in here. We take the outcome minus the average squared, and then we probability weight those outcomes. 5.833. We can also do this. We know the variance of the sum of two outcomes is the sum of the variances. Again, assuming those outcomes are uncorrelated, and for our dice rolls, they are. So again, we've got our outcomes 1, 2, 3, 4, 5, 6, all equally probable. I'm going to calculate this minus 3.5. That was our expected value. Add this up. 17.5. We have to divide it by 6. 2.91667 is the variance of a single toss of a die. If we're adding up two dice, we multiply that by 2. We add it together twice. This times 2, 5.833. So that demonstrates the two formulas we've got, both for expected value and for variance. Now the formula for variance gets a little more complicated if there's a correlation, if those events are related in some way. And we'll see that later in the course, that there's a slightly more complicated way to do this.